In this video, we are going to talk about another sorting algorithm, which is selection sort. If I talk about selection sort, it is one of the easiest algorithm to understand. The concept is very simple. What we do is that, let's say if I have to sort this particular array. So the agenda is simple, that I find the minimum element in this particular array and I place it at the first place. I find the second minimum element and I place it at the second place. Then I find the third minimum, place it at third place, fourth minimum, fourth place, fifth place. Okay, this is the concept, very simple. Let's just see how we can do this in this particular array, and then we will try and run this particular code. And while we are trying to run this code, we will also try and understand this code. Okay, and then we will see the time complexity. So let's say what happens is that I am at this particular place. Okay, so what I have to do is that I have to find the minimum element and replace it here. So what we do is that whichever minimum element we find, we just do the swapping. Okay, so what we do is that we start from here and we find the minimum element from here till end of the array. So we see 4 is here. So what we do is that we swap. So after this particular operation, the array looks something like this. We have 4, 10, 23, 5, 11. Okay, so now this place is sorted. Now I'll go ahead. Now I'm bothered about placing second minimum element at this place. So again, I'll see the complete array. I see this is the minimum element in this array. So I'll do the swapping. So after this, my array looks something like this: 4, 5, 23, 10, 11. Okay, now I go here. Again, I do the same thing. I try and find the minimum element in this particular part of the array. Now, since this part is already sorted, I don't care about it. Okay, I just keep on going ahead. So now I find 10, I swap it. So we have 4, 5, 10, 23, 11. Now again what I'll do is that I'll just go ahead to this particular place, find the minimum element. I find it, it's 11, I swap it. 4, 5, 10, 11, 23. So now what happened was that we already came till second last element of the array, and I already know that n-1 elements are already sorted and are in place, which means obviously that the last place is having the highest element, or basically now my complete array is sorted. So I'll just stop my operations here only. Now let's just go ahead and see how is this implemented in code. So here we have I less than n-1. So we have two loop. The outer loop is basically taking care of the place where we have to find the minimum element. So initially my I will be 0 as it was here, then my I will be 1, then I'll find out which is the minimum element, replace it here, then I'll go to this particular place, then I'll go to this particular place. And since we only ran it till n-2 times, we ran it till n-2 times. So let's say this is 0, 1, 2, 3, 4. Number of elements that we have is 5, but we only ran our loop till my I was 3. Okay, I'm running it 4 times. My bad, I'm running it 4 times, but I'm running till it is n-2. So I'm writing it again in case you got confused. We are running it 4 times. Okay, I goes from 0 to 3, which is n-2. So that is why we have this particular condition that I should be less than n-1. So this is n-1, 4, and it has to run till one place before. So it goes till 0 to n-1. Okay, now let's go ahead. So now what we do is that now we have to try and find out minimum in the rest of the array, and we have to just swap it. So finding the minimum index is taken care by this part of the array. So this goes till from the next element. This goes from next element till end of the array and tries and find the minimum. So let's just try and run 1 or 2 iterations. So let's say initially my I is equal to 0. Okay, so for I equal to 0, let's say I start with j equal to I plus 1. I start from the next element. So I plus 1 is 1, and I go till j will be less than 5. Okay, j will go till 4, till last element. Okay, now what I'll do is that initially what I did was that before starting, like we initialize every time we try and find maximum or minimum, we initialize it with something. So what I did was that I initialized my minimum index with I. So my min is I, which is 0. Always remember that this min is the index of the minimum element. It is not the minimum element. Minimum element is going to be array of min. So what I'm doing is that as I go from here to rest of the array is that I'm trying and see that at any point if I find the element which is less than the minimum that I have till now, or basically at any index if we find an element that is lesser than the element stored at index min, I will update my min to this particular index. Okay, so this is what this particular loop is doing. Okay, so now what happens is that let's say this complete loop runs from 1 to 4. Okay, what will happen is that to after the end of this particular loop I'll have my min with me. So my min will be, again it's 0 1 2 3 4, so my min will be 4, sorry it's 2, my min will be 2. So after this what we do here is that we swap my value at index I to the value at index min. So what I'll do is that I'll swap my 0th index and value at index 2. So my array is going to look something like this. Okay, after this these two indexes value will get swapped. Okay, so this is how for I equal to 0 and complete iteration of j my array looks like this. Okay, now what I'll do is that I'll increment my I equal to 1, I'll keep my min equal to 1. Okay, then my j will go from 0 to j less than 5. The same thing will happen, and again what will happen is that I will find out the minimum index and I'll swap it. So this is what it happens in each and every iteration, and eventually my array is sorted. So this is how the selection sort works. Now let's talk about the time complexity. So let's talk about this particular loop. Okay, so as you can see that in first iteration this goes from I plus 1 to n minus 1. So how many times it will run? It will run 1 2 3 4. It will run till 4 times. Okay, in the second it will go till 3 times, then 2 times, then 1, and we see that we can write it n plus 1 plus n minus 2 plus n minus 3 till 1. And how many times this loop will run? This loop will also run approximately n minus 1 times. Okay, so this thing, if you see, almost is equivalent to the sum of n natural numbers. Okay, this is not exactly, but this is falling very much close. If you could have said that this is, let's say what I do is that I simply add 1 to this. If I simply add 1 to this, this is going to be n plus n minus 1 plus n minus 2. So this is going to be n plus 1 by 2 minus 1. We can write it in this particular way. Okay, so now this is my sum of the n natural numbers. So this is approximately equal to O of n square. So in the worst case scenario, the time complexity of selection sort is O of n square. Okay, what is the space complexity? Space complexity is O of 1. Okay, so now what happens here is that even the best case scenario is going to be O of n square. Why? Because anyways we are going to go ahead and find out which is going to be my minimum. Okay, so this is how the selection sort works. Make sure you write this code on your own as well. It's going to help you a lot. Though selection sort is not something we will apply somewhere, but again this particular concept might help you somewhere. Okay, now let's try and understand another very interesting algorithm, which is insertion sort. Okay, so let's first try and understand the idea of insertion sort. So now let's say you have several numbers or several cards that's there on the table. So let's say they are just kept there randomly. Let's say there's a card with number 1. Let's say there's a card with number 4. Let's say 5 is there. Let's say 7 is there. Let's say 2 is there. Okay, so these are just placed randomly on the table. Now what you have to do is that you have to kind of take these cards and arrange them in increasing order. So let's say you start picking up cards randomly. So let's say they are placed in, let's say, in inverted way, which means that you cannot see the number. So let's say you picked up 5, okay, and you kept 5 in your hand. Now let's say what you did, you picked up 2, okay, then you will just put 2 in your hand. Okay, now let's say you picked up 7. So now what you will do is that you will find the right place for 7 according to this particular configuration. So according to this particular configuration, the right place is here, right, after 5. Let's say you keep it after 5. Now let's say you pick up 4. So now what you will do is that you will find out the right place for 4. So right place for 4 is in between 2 and 5. So you will put 4 here. Then let's say you pick up 1. Then you will find the right place for 1, which is here. So this is the concept that is used in insertion sort. So in case of insertion sort, what we do is that we start from this particular number, okay, and we keep on going ahead. Now what happens is that we just check that what is the right place for this particular number, and what we do is that we just put that particular number in that particular place. So what happens is that as you keep on going ahead, the first half of the array, or this particular portion of the array that is before this, will be sorted, okay. And what we have to do is that we have to just put the number at the required place. So what we will have is that we'll have a certain part of the array that is sorted, okay, and then let's say there is a number x, and then there is an unsorted array, okay. So what we do is that at any time, let's say I'm on x, I'll find the right place for x. So now what happens is that I find the right place for x, and then this part of the array becomes sorted, and then we have another number, let's say x dash. I keep on doing the same thing, and eventually the complete array becomes sorted, okay. Let's try and do this for this particular array. So now what I'll do is that I'll start from 7, okay. I'll try and find the right place for 7. So now we see that 7 is already in its right place. So I'll just go ahead, I'll go to 6. Okay, now what I'll do is that I'll compare 6 with its previous number, just previous number. I will see that is 6 having a value that is greater than or less than the previous number. So as you can see that 6 is having value less than 7. So what I'll do is that I will simply go again, I'm just finding the right place right now, okay. We will see how we are just switching and swapping. I'm just trying to find the right place. So now I'll go ahead, and then I'll find that, okay, I can put 6 in between 1 and 7. So maybe what I'll do is that my array will be 1 6 7 8 0 9 4 5. So now this particular part of the array is sorted. Now I'm bothered about 8. So I see that 8 is already in its right place. So now this part of the array is sorted. Now I'll come to 0. I have to find the right place for 0. Now what happens is that I check for this place. Is this the right place? So is this the right place? Is this the right place? Is this the right place? So what happens is that there's a condition in which I have explored the complete array. Still we didn't find the right place, which means I have to put it at the first place. So I'll put 0 1 6 7 8. Okay, now this part of the array is sorted. Now we have 9 4 5. Okay, so now we have this particular number. I see that this is already sorted. So this part of the array is sorted now. Now I have to bother where I can put 4. Okay, so what I'll do is that I'll again start from here, 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 here. So I can see that I can put 4 between these two numbers. So I'll put 0 1 4 6 7 8 9. So now this part of my array is sorted. Now I have to find for 5. Now I see that I can put 5 in between 4 to 6. So now I put 5 here. Now the complete array becomes sorted. So this is the concept or crux of insertion sort. Now the question is, how do I find the right place? Okay, and how do I find the right place, and how do I put the number over there? Okay, that is the question. Let's see how we do that in insertion sort. First we will just try and do this for an array, and then we will see the code. Okay, so now let's say this is the number. So what we do is that for 6, let's say for 7, what we do is that we just check with the previous number. So there are two situations, that the previous number is smaller than this number. Okay, let's call it current number, current, and let's call it prev. Okay, so at any point, let's say this prev, let's say it's either smaller than current. So either we have prev smaller than current, okay, or we have prev greater than current. Okay, so now what can we conclude? So now since we know that this particular array is already sorted, this particular part of the array, as we see, is already sorted. So if this number is smaller than this particular number, which means it's going to be smaller than rest of the elements also that is coming in the left. So what I do is that I just don't bother and I just stop there only. Okay, now let's say there's another situation. Let's say there is 6. Okay, so in this case what is happening is that 7 is greater than 6. So I know that I will find some place. This is greater than this is greater than this number, so I'll find some place. So what I do is that, but I'm not sure is this the right place. So what I'll do is that I will go ahead. So now I know that this 6 is smaller, sorry, this 1 is smaller than 6, which means I can put 6 just after this. So what I will do is that I'll have to put 6 after this. How I'm going to do is that I will first check that if 7 is greater than 6. If 7 is greater than 6 or this particular element is greater than this particular element, what I will do is that I will store 6 in some variable. Let's call it var. I'll store 6 in some variable var. This is the crux of whole insertion sort, so make sure you understand well. Okay, I put var equal to 6, and then what I'll do is that I'll push the elements to the right. So what I'll do is that I will put 7 to this particular place. So after the operation, it will look something like this: 1, 7, 7. I'm just talking about this particular part right now. I'll talk about the next part as we go ahead. So now I checked for this particular part, okay, and now what I'll do is that I will go ahead. Now I'll check this number with this particular number. Now this particular number is smaller than this number, and this number was larger, which means that we can put 6 here at this particular place. So now what I do is that as soon as I get a place, basically as soon as I find an element which is smaller than this particular element, which means this one has to go just after this. So what I do is that this is the place where I have to put 6. So what I do is that I will simply put 6 at this particular place. Okay, so I do 1, 6, 7. Okay, so what I did was that as soon as I found the right place, I just put 6 over there. Now let's go even ahead. So the next number is 8. I don't bother about 8 because here only I see that 7 is less than 8, which means that it's going to be smaller than rest of the element as well. Now let's see for 0. That will give you good understanding. Okay, so now let's see for 0. This is my latest array that is looking. So now what I'll do is that I'll compare 0 with 8. So first of all, I'll store 0 in a var. Okay, now what I'll do is I'll compare 0 with 8. Okay, now what is happening? This is greater. So now I'll just copy this particular thing here. I'll copy 1, 6, 7, 8, 8. This is how my array will look. Let me write it here. This is much space here. 1, 6, 7, 8, 8. This is the latest status. Now what I do is that I compare 0 with 7. Okay, again 7 is greater than 0. So I do 1, 6. Again I'll copy 7 here. 7, 7, 8. This is how my latest array looks. Now I go here. 6 is there, again greater, so I'll copy 6 here. So it will be 1, 6, 6, 7, 8. Okay, now I check with 1. 1 is also greater, so I'll simply make 1, 1, 6, 7, 8. Okay, so now at this particular place, what has happened is that my array has already come to its leftmost place, which means that 0 has to come here only. I can't go any further. So what I simply do is that I have found place for 0. So whensoever I find the place, I will simply at that particular place, I will put my var. So now I put 0 here. Okay, so this is how I have found place for 0. Now this is my latest array. I have to put 9. So 9 will go as it is. Let's see for 4. Okay, so let me write it here. 6, 7, 8, 9. Okay, so now after first iteration, what will happen? I'll check 4 with, let's say 4 was initially here. I'll check with this. This is not the right place. So I'll just copy 1, 0, 1, 6, 7, 8, 9, 9. Okay, just after this, it's going to be 0, 1, 6, 7, 8, 8, 9. Now I'll compare with 7. It is going to be 0, 1, 6, 7, 7, 8, now 9. Then I'll compare with 6. It's going to be 0, 1. Let me clean some space. So this is a small eraser. Okay. Yeah. So now what we do is that we were here. So again, we check 4 with 6. 6 is greater. So I just copy 6. So it's going to be to the next place. It's going to be 0, 1, 6, 6, 7, 8, 9. Then what will happen is that I check with 1. So now since 1 is smaller than 4, which means I can put 4 over here to the next place. So I simply put 0, 1, 4, 6, 7, 8, 9. So I put 4 here. So if you see what is happening here is that I am trying to find the place for 4. And what I am doing is that till I am finding the place, I am just asking rest of the elements to make place for 4 just by shifting to right. So what I am doing is that I am like, will I sit here? No. So can you please move a bit right? Can you please move a bit right? So every element is making place for 4 by shifting to the rightmost element. So what happens if you sit in a metro or something, you will find this place, right? If someone just wants to sit in between, everyone tries to go a bit right, and whenever there's a sufficient space, the person just sits. Okay, so that is a similar situation that is happening over here, and this is the whole idea of insertion sort. Let's just go ahead and write the code and see the code of insertion sort, that how this particular thing is written in code. Okay, so this is the code of insertion sort. I hope it is visible. So now what happens here is that I have taken the same array. So we have v and j. We have taken these two variables. Now let's see what happens. We have I equal to 1. So basically I starts from here. Okay. So basically I is the element for which is the index of the element for which I am trying to find a right place. So now we store v equal to ri. We store v, and then we have j equal to I. So what we do is that basically j is doing the task of comparing previous elements. So let's see. So what we do is that we run a loop. So what we did was that we ran a loop till all the elements were greater than that particular element. So we kept on running and we kept on moving elements to the left unless we found an element which was smaller. So as soon as I found an element which was smaller than the element I have to shift or I have to adjust, what I did was that as soon as I found the element which was smaller, I just stopped my loop, I broke my loop, and what I did was that I just placed the element at the right place. So let's see what is happening here. So here we have this particular element. Okay, so now in this case I have to let's try and dry run it. So we have I equal to 1. Initially my j is equal to 1. Okay, j is equal to I, and v equal to arr of I, which is 7. Okay, so I check a loop. I check a condition here that arr of j minus 1 should be greater than v. So in this case, arr of j minus 1 is this particular thing, arr of 0. Let's put the index 0, 1, 2, 3, 4, 5, 6, 7. So arr of 0 should be greater than arr of 1, which is arr of 0 should be greater than v. So v is 7 over here. Is this particular condition true? No. This is not greater than this. So we just come out of this particular loop, and what we do is that we put arr of j equal to v. So j is still 1, so it will just be sort by its own value. Now we go to here. Okay, my I gets incremented, my I becomes 1, my I becomes 2, my j becomes 2, and my v becomes 6. Okay, now I again run this particular loop. We check while arr of j minus 1 is greater than v. So we check whether this is greater than 6. Yes, it is. So what we do is that we just copy arr of j equal to arr of j minus 1. So arr of j is 2. So now it becomes arr of 2 is equal to arr of 1. So this as a result copy. So it becomes 0, 1, 7, 7. Yeah, it becomes 1, 7, 7. Now we decrement our j. Our j was 2, our j became 1. Okay. So now what we do is that we check if arr of j minus 1 is greater than v. So basically we are checking for this one. Arr of j minus 1 is arr of 0. So we are checking if 1 is greater than 6, which is not the case. So we come out of this particular loop. And as soon as we come out of this particular loop, what we do is we do arr of j equal to v. What is j here? 1. So we put arr of 1 equal to 6. So we get this portion as 1, 6, 7. So this is how this portion works. Now 8, what we will do is that we'll make our I equal to 3, okay, and my j will be 3. Now I do the same thing. I check while arr of j minus 1 is greater than v. Arr of j minus 1 is greater than v. No, that is not the case. Arr of j minus 1 is arr of 2, which is not greater than v. V is 8. So we come out of this particular loop. Now again my loop gets incremented and we go to I equal to 4 and j equal to 4. So in this particular case, what happens is that this condition keeps on being true, and here we have a situation that j should be greater than equal to 1. So what will happen is that we keep on going ahead and eventually my j will become 0. and when my j will become 0, we will come out of this particular loop and eventually this will get executed. So we will keep on copying, so the element will just keep on shifting right, and when this arrow of 0 equal to v will get executed, then we will have 0, 1, 6, 7. So this is how slowly and slowly this particular loop will just sort the complete array. So insertion sort is simple if you understand the basic concepts. Sometimes it's confusing, but if you understand the basic concepts, trust me, you will never forget it and you will remember it very easily. You will understand it very easily. Okay, so just remember that you have to find the right place for a particular element. At any point you have to find the right place for a particular element, and the way to do is that you keep on going to the left, and while you keep on going to the left, if you don't find the right place, just keep moving elements to the right. As soon as you find the right place, just copy it there. Okay, that's how it is. Now let's try and see the time complexity. So if you see, the time complexity for this is going to be O of n square in worst case. Okay, so what will happen, what is happening is that we start from here, right? We start from here, we run it 1 times. Okay, so this, how many times this loop runs? In worst case, just see how many times the loop runs is that we start from here, then we go till here, then we start from here. So it's going to be 1 plus 2 plus, this is how it's going to be. It's going to be running like that, and we have seen is that this gives us the time complexity of O of n square. This is the worst case time complexity. Space complexity in this case is going to be O of 1, because this is an in-place sorting algorithm. We are not using any other algorithm. Sorry, we are not using any other space. Now, what is going to be the best case time complexity? Just think around when do we have the best case time complexity? So we have best case time complexity when our array is already sorted. So in that case, what will happen is that we will have this condition just once. This condition will be checked just once, and we won't be having this loop again and again. In that case, the best case time complexity is just O of n. Okay, and one more thing is that there might be some MCQ question that for a partially sorted array, which is the best algorithm. So insertion sort works really well with the partially sorted array. So that is all about the insertion algorithm. Make sure you understand it well, and we will go ahead and understand more algorithms. Now let's just try and understand the time complexity. So let's say the worst case time complexity is going to occur when we have reverse sorted array, okay, or array sorted in descending order. So in that case, we will have, let's say, 5, 4, 3, 2, 1. So let's say my loop will start from here, okay, so it will run 1 time, okay. Now this particular loop will just run 1 time, okay. Now what will happen is that we come here. For this place, the loop will run 2 times, okay. For this place, the loop will run 3 times. For this place, the loop will run 4 times. So basically, we will have something like, just like we saw earlier, 1 plus 2 till n minus 1. So this is number of times the loop will run, and this is going to be sum of n minus 1 and natural number. So it's going to be n into n minus 1. So it's generally n into n plus 1. So this is the n plus 1 thing, and this is n, okay. So basically, the general formula is n into n plus 1 by 2, okay. So if we put n minus 1 here, this turns to n, and this remains n minus 1, okay. So now this is 2. So this is equivalent to n square. So the worst case time complexity is going to be O of n square. Let's see the best case time complexity. The best case time complexity occurs when the array is already sorted. So let's say 1, 2, 3, 4. In that case, what will happen is that we will go to each and every position. This loop will run as it is. This will run n number of times. And what will happen is that for each loop, for each iteration, or for each I, this particular part will run just once. Okay, so we will just go ahead, we will check, this will become true, so we are not going ahead. So this particular loop will just run once, okay, we will come out of this particular loop only. So the time complexity is going to be O of n for the best case scenario. In general, if someone asks you what is the time complexity, so you generally talk about worst case time complexity, okay. And what is the space complexity? We haven't used any extra space, so it's going to be O of 1 space complexity, okay.